And I did want to just give everybody a quick announcement before we jump into the lecture. So my graduate assistant, Kristen Massey, who's on, and she's going to be joining our classes moving forward. She's actually going to start hosting some virtual office hours, both for BUDA 450 and the Accounting 493C students. So she'll be an additional resource available to you all. Her office hours will start next week. She's going to be doing some time on Wednesday mornings and Thursday afternoons. So we'll be sending out some communication about this, but just wanted to give you a little bit of a heads up that Kristen is going to be able to help Brad and Dr. Schaub and myself on this. And she took the course a couple of years ago herself, so that'll be a really helpful resource. So, all right, and Brad, I'll let you go ahead and.
Yeah. No, give me 1 second here to share my screen, everybody, and we'll pick up where we left off last time. We're gonna finish this stuff off today. Again, hope everybody had a good weekend. You guys can't see my screen yet. There we go. You guys see it now, okay?
Yes.
Awesome. Let me get it all set up here. I apologize. I had a meeting right before this. All right, so a couple things as we kind of go from where we started last time. One of the things we started talking about were matrices, data frames, lists, and vectors. So let's start back from the beginning here. And this is where we'll pick it up because we had some questions. We're going to look at an example of especially matrices, data frames, and vectors. So one of the things you guys have seen, and one of the things you'll continue to see at least, is, you know, the different data types we have. These are the different storage types. So if you remember the different data types, it's text, it's character strings, right? It's numeric, it's logical, it's all those fun things. Now, who remembers the difference between like how I define a matrix? If you look at a matrix, think of it as an Excel file. And what do I mean by that? It has rows and columns, right? All the same data type, okay? A data frame, it's an Excel file that can have different data types. Now, we've seen some examples of this stuff, okay? We've seen some examples of how this can work. We've seen some examples of how everything can kind of work together with this. We've seen it in the Big Mac data. Remember, we had integers and numeric. Difference between an integer and numeric is, does it have a decimal, right? Integer is a whole number. That's the way you guys said it, not me. So when we look at this, just keep that in mind as we go. A list, I want you to think of this as like the stackables Rubbermaid makes, right? It's just a bunch of bins put together where you can put anything you want in. It doesn't have to be the same length. It doesn't have to be the same style. It doesn't have to be anything. It's a bunch of storage bins, okay? Then all I want you to think of a vector of is a column of an Excel file, okay? Now, as we go through this today, you're going to start seeing it. Now, the two things we're going to get done today, the two things we're going to push hard to get done, is one, we're going to go through and we make sure we understand these. The most important ones for you all are on line 351 and 352. You're going to hear me say this over and over again, and Kristen may roll her eyes when she hears it because she's heard it before. The idea is a data frame looks like a matrix, acts like a list, okay? Looks like a matrix, acts like a list. It's going to have rows and columns in it, but it's going to function like a list. And the reason we care so much about these are data frames are how we read data in. We've seen every data set we've touched so far has been a data frame, right? A list, though, and a lot of those functions you have output of, a list is how it comes back because it's trying to give you a lot of information at once, and it's a lot of different type of information. Your job as an analyst is to process that information, but you also need access to it. So it's how you're going to gain access, okay? Now, let me show you a couple of things, and I'm just going to create a few things here just so we're all on the same page. So first things first, I'm going to create a matrix A. Now, have we talked about the arrow yet? You guys remember what the arrow is? Okay, the arrow, this means it's called the assignment operator, okay? That's the real fancy name of saying save as. What I want to do is I want to take whatever is over here on the right and save it as A. All right, so let me pull this over here a little bit and you guys can see what's getting ready to happen. Clear this out. Don't want to do that. You'll see it pop up here in a second. But what I'm going to do is I'm going to save this thing as A. So I'm going to create an R object called A, and it's going to be this matrix. Now, first thing, let me show you what the output is. The output of this piece of code, right? And I just highlighted it and hit Command Enter, is a 3x3 matrix. So let me pull this up just a little bit here. It's a 3x3 matrix, okay? When I say 3x3, 3 rows, 3 columns. Now, let me show you a couple things that happen here. This is a piece of code I want you to understand and remember. 1:9. What this does is it gives me the integers 1 through 9, okay? Fair enough? And all I'm doing here is I'm saying create a matrix, and all it has is the integers 1 through 9. I want 3 rows, 3 columns, and I want you to fill it out by row. Matrices have rows and columns, right? So what it does is it starts here in 1, 1 and goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, think about a matrix. It has to have all the same, okay? Do you agree with me that all these numbers are integers? Integers, whole number, right? All these numbers are integers, so this works. Everything here works, all right? Let's change one thing. Let's change this by row to false. By row equals false means we're going to fill out these columns. So when I run it, it's the same exact code, except now it should go 1, 2, 3. Let's see if it does that. All right. Now, what we're seeing is this looks like a matrix to me. Only thing that's changed is the data now goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the first thing I want to ask you, and I'm going to show you these commands. With the data storage type, we can always ask it, is it something? So is dot matrix A? All this is saying is A a matrix? Well, the answer should be yes, because I created it as a matrix, right? Helps if I save things. Is matrix A true? Came back as true, right? And you can see this has saved my matrices up here. All we're doing when we use the assignment operator is we're saving them so they appear up here, okay? Now, the other thing, the Big Mac 2003 data set. You guys remember the Big Mac 2003 data set? Y'all sick of that one yet? All right, you'll get sick of it at some point. We'll keep using it until you are. Now, let's check and see if it's a matrix. Come on. If you ever get something that doesn't work, hit this button right here. What it does is it runs all code up to that point, okay? So if I check to see if this thing's a matrix, what it's going to tell me is false. But here's what I want you to look at. Big Mac 2003. It has rows and columns like a matrix, right? What keeps it from being a matrix?
Is that it's got different like values, like for instance, like tax rate versus like bread, like it's not the same unit.
So what you're, not that it's not the same unit, look at it. One's a decimal and one's not, right? Would you agree with me there?
Then I guess it's like what, like an integer type or something?
It's the difference. Remember, a matrix, it all has to be of the same type, right? We have to have the same data type. Are you with me on that? So here, because I have 2.00, what is it telling me? It's telling me that's numeric, that's decimal, right? Verse 9, not 0.00, just 9, it's an integer. Now let me show you what happens on one thing. Now here's a cool trick on something, just so you can see it. I want to take the first value of A, and I want to make it equal to 1.2. Now remember what A is to begin with. It's just that matrix, okay? I'm going to say A11, remember this is first row, first column, right? Equals 1.2. What it did, it took everything in that column and turned it to the 0.0, right? See how it makes that adjustment? See how it makes that change automatically? It's treating these the exact same way. Here's the one thing it's not doing. This is printing in a summary. So now it just changed everything to numeric. Up here, when we were talking about Big Mac 2003, it has some other properties that are going to make it not a matrix. So let's talk about those. All right. Now, Data frames. Data frames resemble matrices in R, but do not function like them. The best way to check to see if something is a data frame is to use two commands. Is.data frame or names. Is.data frame is the best way to do this. Okay. Why? Because it's going to say, is it a data frame? Big Mac 2003 is a data frame. Great. Awesome. What's that mean? It means it has certain properties, but what it means is it looks like a matrix, functions like a list, which means it has things you can access. So it has this pretty square rectangular form where we have rows and columns. Remember, the rows are observations, the columns are variables. Everything works great, right? So this is the number of minutes of labor in Amsterdam that it takes to afford a Big Mac. But now what we're doing is we're able to access these things that are named. So again, let me run this. Names Big Mac 2003, it gives me the names of the things I'm able to access. So what I'm able to do is use that $ or the atomic operator we talked about to get access to it, okay? It allows me to get direct access. Now, the other place this is true is a list. And a data frame is a special case of a list, okay? So let me show you how to create a list. Let me show you how we function with lists. First things first, 1:9. Gives me all integers 1 through 9. You guys agree with that statement? 2:5 should give me what then?
Numbers 2 through 5.
Numbers 2 through 5. Numbers 2 through 5. All right. Hey, that's what it does. Awesome. Now, would you guys agree with me? There are not as many numbers in 2 through 5 as there are 1 through 9. Everybody agree with that statement? All right. Give me 1 second. All right. Now, I just saw the chat, guys. I'll get to those questions here in 1 second. Now, here's what we want to do. We want to contain these things together. Imagine what you want this to be is you want to have different elements and different things in different parts of your list. I told you to think about this as one of those Rubbermaid containers, right? What we get when we create a list, we say my list is a list. It has an element A called 1 through 9 and B 2 through 5. And we're going to say it's my list. So when I type in my list, what I see is I have this first element called A. Think of this as the top of that stackable, the top of your drawer, that top drawer. It has 1 through 9 in it, right? Then we have something called B, which is 2 through 5. Now, here's a way to think about this. Let's say I want to try and keep customer information someplace. And what I want to do is I want to keep sales records. So this could be the customer name. And this could be the amount of money they've spent on each transaction. See how it doesn't care? It doesn't matter. We're able to call it. We're able to access it. Now, once we have this thing saved, what we can do is we can say, okay, what are the names in my list? You have things A and B. What's in my list A? There it is. You can call it directly. You can call it directly by its name. Now, here's another way to do it. You can call the first and second element using these double square brackets, okay? Using these double square brackets. So that brings back customer name, which is the first element. Second element is just then how much money they spent. Lists are the most flexible data type we have. They allow you to store anything. They just do it with no structure. All right. Now, somebody asked a second ago, it was Chris, could I give a possible example of a matrix? Matrix is anything you want to store. You can create it for yourself, anything you'd want to do. We'll show some examples as we go, probably later in the semester, about why you would want to store data in this way. But think about it right now. Just some stuff I'm thinking about in the moment is think about what I want to do is I want to track number of COVID cases over time by county. I'm going to do that in a matrix because it's all just going to be counts. All right. It's all going to be counts. That's one way to do the storage. It's a quick and dirty way to store it. Chris, you got your hand up. What's up?
Yeah, I had a question, actually 2 questions. One, and like, what would be an example of why would we use matrix? Like, for example, like to channelize it or for whatsoever. Another question was, can we compare it with arrays?
Can you compare it with what?
Array?
Array?
Yep.
Yeah, so a matrix is a special form of an array. Array is just multidimensional. A matrix is just a two-dimensional array.
Okay, that answers my question. And what could be the possible example of usage, like where we can use it?
So you can use it a lot of things. The one thing that a matrix does that the rest of these don't, that you can't do on a data frame and that you can't do on a list, is you can't do mathematical operations, or you can do mathematical operations. So we can add, subtract, multiply, divide. We can't do that on lists, and we can't do that on data frames. So it's kind of like a numeric storage vector. Does that make sense? So an example would be like, I want to sum cases over time, like I just mentioned. It's actually the least used. Part of the reason I start with it, though, is because it's the most restrictive and the simplest. Data frames, little less restrictive. You still have to have that square feel to it, that rectangular feel. Arrays are an absolute free-for-all, okay? Here's what I want you to remember, though. Coming back to data frames actually have importance because we have these operators. Data frames are lists, right? We're able to name things in them, but they have this structure. So when I look at Big Mac 2003, you see this pretty structure, right? It feels like an Excel file. You guys agree with me there? It prints like a matrix. It prints in that rectangular form. Looks like a matrix, but then it allows me to come in and call these different variables by name, right? So it's stored like a list. It's stored like a list. All right. Does that make sense to you guys? Do you understand the concept of a data frame? It prints like this matrix, but we're able to call variables just like this. We're able to call variables by name. Is everybody okay with that concept? That's actually really important for what we're going to talk about the rest of the day. Y'all good with that? If you're not, ask a question as we go through it, okay? All right. Conrad, you asked to see that piece of code. All right, so just to clean it up a little bit. Matrices, really restrictive. You've got to have the same number. We can do some math on it. All right. Lists, really flexible, but can create complete chaos. Data frame is that nice balance. It's our Excel spreadsheet that we can operate on in R. But we have to operate on each of the columns by themselves. We have to operate on each of the variables by themselves. And I'll show you that here in a second, okay? All right. Here's some ways about missing values work. We'll come back to that. That's not really as important as we want it to be. Here's some things about random number generation. Again, this is for you all because I know you've taken a stats class before just to get your feel. It's not really relevant to what we're doing right now, okay? Again, this is the type of stuff I'm giving you all, but for where we're trying to go right now, I want to come clear down here to the bottom. Clear down here to the bottom. Line 695. Introduction to the tidyverse and the pipe operator. So I'm gonna give you a little history lesson first too. R until, what year did I graduate? R until 2014 was used by research statisticians and absolute math nerds like me. Okay, I mean, that's just what it was. That's how we used it. That's how we thought about it. And then there was this guy came along named Hadley Wickham, and Hadley kind of changed the face of stuff because what he did was he started building out this thing called the tidyverse. And what it was is a much more readable format of code. All right. The code we've been looking at before, it looks kind of disjoint, right? Looks kind of disjoint. It's kind of hard to follow. His goal was to create something that was readable from a code-based standpoint. Now, I wouldn't do my job if I didn't tell you it has a lot of flaws in it. But anything that is readable is going to be restrictive, and I'm not going to like it. Because my whole goal of coding is to do what I want. Like I like that I can make a computer do what I want it to do. The tidyverse is going to put some guardrails on us. But what it turns into is really readable code. How many of you guys have taken SQL or know any type of SQL or SQL? The thing I like about SQL is it's very readable. Would you guys agree with that? Like it's almost like reading a sentence sometimes. The tidyverse has that same concept, okay? The tidyverse has that same concept. Now, it works on what we're going to call a pipe operator. All right. What I've just highlighted right here and what I'm running circles around, that pipe operator, what it does is it takes an input and pushes it out into something, okay? So the input's going to go where my cursor is flashing, and then we're going to write the next piece of code to push it into. All right. Now, what we're going to say is this is going to create a much more functional form. Now, it's turned into 1,000 different ways to do a bunch of different things. But what we're going to do is we're going to load up a library called Dplyr, Dplyr. So you guys can go to packages, go to install Dplyr. Now you'll see there's a bunch of Dplyr functions. Dplyr is one of these things that started it all, okay? It actually started this entire functionality of what we call Dplyr and ggplot. It turned it into what they call the tidyverse. What the tidyverse is, it's a compilation of about, I think it's 15 packages now that does anything you want to do, but it all comes out of a company called RStudio. All right. And this is while Hadley was getting big, RStudio was getting big, and Hadley became the chief scientist at RStudio. So whenever you see Hadley Wickham's name, he's the chief scientist at RStudio. He used to be faculty at Rice, really smart, really great at programming all this stuff, has created a bunch of cool stuff, and R wouldn't be where it is without him. So I kind of credit him with the person who took R from this cute little, research assistant language to it's actually used in production in Fortune 100 environments. All right. So go ahead and install Dplyr. I'm going to hit no because I don't want to restart my R session. You guys should go ahead and install it and do everything you're supposed to do there. It may take a second to install. Now I'm going to show you a couple things because this pipe operator is really important. Last time around, I showed you head Big Mac 2003, right? If you guys remember what head Big Mac 2003 does, is it says, I want to take the head of Big Mac 2003. You guys with me on that? Remember what the head function does? It gives us the first 6 observations. When I run it, it gives me the first 6 observations, okay? Now, how do we do this with the pipe operator? Because the pipe operator is really important. What the pipe operator is going to do is it's going to read a little bit different. It's going to say, I want you to take Big Mac 2003 and put it inside a head. I want to take the head of Big Mac 2003. So the way we read this, Big Mac 2003, use function head. So when I run this, notice, it's the exact same thing. Oh, come on. You're not going to like me today. Guess I've got to do it. There we go. Catherine, do you want to run them through this while I debug this? Because of course this is going to happen today, right?
No problem. I've got it open here. So just give me 1 second. And I always like to use Dplyr, so hopefully I won't have any issues.
Catherine is the Dplyr expert of us too, because you guys will figure out I'm a little bit more old school in my code base compared to how Catherine writes. And part of it comes because I've been programming in R since about 2006. When Hadley turned this on its head and started using all this, again, I'm not a tidyverse native. It's not something I learned R in. I learned R from base. I learned R the way I was showing it to you all. So from that perspective, what we're seeing or what you're seeing is you're going to see a mix of code from me. Sometimes it's easier to write in Dplyr. Sometimes it's easier to write the other ways. What you'll see is kind of how that progresses through. Okay.
Hey, what line were you on?
704, 705.
Okay, cool. All righty. All right, 1 second. There we go. All right. Let me just load this in real quick. And
You should be good to go from there down.
yeah, I gotta get this out of my
Oh,
in line. It drives me nuts. Okay. Alrighty. So yeah, as Brad said, we ran head Big Mac 2003. I don't have it loaded in, just a second. There we go. Okay. And then if we use the pipe operator, should give us the same. Yep. So you see down here in my console. So we applied the head function to what we piped into that function, which is Big Mac 2003. So it was the same as writing it out the way that we did before. It just starts to follow a flow of logic, if you will. And you'll see as we continue, we can start to pipe the output of one. You could add another pipe operator and pipe that into another function. So we could add another function onto this, and it would basically take this top portion, the top 6 rows, and pipe it into something else. But we'll show a better example of that as we get a little bit further along. So, all right. So here's just some more examples. So this iris, iris data set, we'll actually look at it real quick. So we'll go down here, type in help iris, and see what it gives us. And it'll pop up over here in our bottom right menu, or you could have typed it into the actual search function in your help tab there. The iris here is a data set. It's a data frame with 150 rows and 5 variables, which we'll look at those details here in just a minute. And it looks at sepal length, sepal width, petal width, and species of different irises, like the flowers. So let's take a closer look at what that looks like. So we'll go ahead and use our pipe operator to look at some functions we're already familiar with. So we're going to look at head of iris. Again, that gives us our top 6 rows, and you'll see we have our different variables: sepal length, sepal width, petal width, and species. We can also look at the dimensions of our data frame here. It matches what our help file said, which 150 rows, 5 columns or variables. And we can also go further and start to look at, let's do the summary function to look at the details of all of our different variables. So we'll run that. And you see here, sepal length is a numeric value since it's giving us min, max, mean, median, and our first and third quartiles, all of our quartiles there. Same with sepal width, petal length, and petal width. So those are all numeric variables there. Species, however, though, this is now a categorical variable. So it's showing that out of our 150 rows or observations, we have 50 that are type setosa, 50 that are type versicolor, and 50 that are type virginica. So those are the 3 species of irises that are captured in this data frame. Okay, and that's going to play a role down here as we start to look at some functions that live within the Dplyr package. One thing I will say, and we'll expose you to some of this when we get into another component. In our next module, we're going to start looking at ggplot, which is part of the tidyverse as well. There's some what they call out their cheat sheets, and those can be really helpful. We're going to just scratch the surface of all the different functions that Dplyr is capable of, but they're very similar to ways of sorting and filtering your data in an Excel file. But there's even more it can do beyond what we're going to show you in our lectures, and that Dplyr cheat sheet can be really helpful. So if you literally just Google Dplyr cheat sheet, it'll pop up, and I reference that a lot when I'm cleaning data. So the filter function in Dplyr, this allows us to We're going to feed it a data frame. So right now we're working with our iris data frame, and then we want to filter for a certain condition for a variable. So let's say down here, we want to filter for species being Setosa. Okay, that's the example we have here. So we want to create a new data frame out of that. I mean, you could just run what's to the right of this if you wanted to, but it's not going to necessarily save that in your environment. So if you want to save the output of any of this, data cleaning that you're doing, you want to make sure that you're naming a new object in your environment. So we have here Setosa only is what we're going to name our new data frame. Iris is going to be the original data frame that we're going to feed into this filter. And as you look up here, we said filter, and then we have two arguments. We have the data frame itself, and then the second argument is the condition of that variable, what we're actually filtering on. Now, what you have to remember with the pipe operator is if you have a function with multiple arguments, whatever's on the left of the pipe operator, that's going to be your first argument. So you'll see here filter, we're not putting iris back in there because iris was on the other side of the pipe operator. So it automatically knows that that's your first argument. It would be the same as doing filter iris, comma, species equals Setosa. Okay, so let's go ahead and run this. And you'll see that it did go ahead and save this new object in our environment over here. So let's take a look. Let's run the next line and see what the output of that is. It's going to show us the entire data frame. We have 50 observations, which makes sense because when we did our summary of all of our variables in iris, we knew that there were 50 that were species Setosa. And so now our new data frame just has those Setosa variable Setosa species irises. Okay. Now we can also filter on continuous variables or integer variables. And when we do this, we're going to use greater than, less than, we can use the equal sign if we wanted to. So our other 4 variables were all numeric variables. They were all continuous. So we can go ahead and show an example with one of those. So now we're going to look at, we're going to go back and use our original data frame, the iris data frame. We're going to create a new object, a new data frame called long petals. So we want to look at those that have petal length of greater than 1.5. So we'll go ahead and filter that, create our new data frame. And then we'll look at that. We're just going to look at the top 6 rows because it's a little bit of a longer data frame there. And you'll see petal length as we look, we see all of these values of greater than 1.5 in petal length. You could add in, if you wanted greater than or equal to, you would just add in greater than and then the equal sign there. So it's the same as, your math operators. It functions the same way here. Brad, you want to add anything before I go into select?
Yeah, just 1 second. Scroll up just a hair there. So, I mean, just a couple things. You see it from a normal, you see it there. The less than or equal to operator, if you want to just show them that real quick. So less than or equal to.
Yep.
So this is how we're going to do less than or equal to. There's also some ors and ands that we'll show you as we go. But for right now, this is the way you're going to subset data a lot of the time. And again, where's this going to come up? There's a lot of the time where you're only looking for dates that are past a certain period, right? There are times where you're only looking for certain customer segments or certain organizations that are going to be in your larger data set. One of the problems we talk about with big data a lot is just it's massive in size. The truth is what you need to analyze most of the time is actually manageable. Okay. So understand the balance between those two and understand, and this is something, I'll harp on a lot. Catherine will hit on a lot. Like you'll never get past it with us. What problem are you actually trying to solve? And does this data set do that? All right. That's the first thing you have to answer before we get into R, before we start doing all that stuff. But this is where it starts, on the ability to filter, on the ability to do selects and things like that. So just my kind of 2 cents on that.
All right, so the select function is also part of the Dplyr package, and it allows us to subset our variables from a data frame. So Like the notes say here, think of this as doing a column reduction of the data set by name. So we'll go ahead and show an example of it. First of all, the select function, again, we're going to feed it a data frame as the first argument. And then we can select on multiple variables. We can select on just one or two if we wanted to. So let's look at an example. So we're going to subset iris on sepal length and sepal width. So we'll run this. And again, let's look at the first 6 rows. So we've now just selected those 2 columns within that entire data frame. Okay, we still have over here, we'll just go ahead and run dim subs and run that line. We still have all of our observations when we use the select function. We still have all 150 rows. We just are now only going to look at two columns of the variables there because that's all we really need to keep. I will tell you, when working with really, really large data sets, especially, ones that have a lot of qualitative and quantitative data behind it, it can save you a lot of, headaches and like literal headaches and eyes going crossed if you can weed out some of the columns that you're not going to need in your analysis. So a real quick way to do that is to use the select function and just select the columns that you plan to use in your analysis. Okay. Then we have our group by function. So this just orders data by a factor. So if we want to make sure in this example, again, we have our 3 species. Originally our data frame might have had them all intermixed together, but we might want to group it by individual species. And then from there we can analyze based on those groups. And we'll show that here in a bit. But so again, we're going to create a new data frame called keep. That's going to group ours. If you look, we now see setosas are all at the top. We could also go look at the whole thing, but again, it's still keeping our 150 observations. We can run dim on it just to make sure. And that'll help. Yep, so we still have our 150 rows, but now we've grouped it by species. Especially if it's the same as the sort function in Excel, is this group by function.
So
go ahead, Brad.
So let me give you 2 other things on that. That group by function is actually your friend in a lot of cases because of what Catherine just said, right? It's like a sort. But what it does is it splits the data into groups. So let's say you wanted to take the average after the fact. It allows you to do that group by and then take the average. So there's an operator. So what you're able to do, some of you all may have heard of segmenting, right? You're able to segment data and then you're able to do a calculation on it by segment. So not only does it sort it when it prints it, it does this calculation that comes after it. So as we get into more complex, like what we're getting ready to see with group by and summarize and all these things down below and arrange, you're going to see how this function really works. So it's not just a sort, it's an operation on top of a sort. When it prints, it's going to sort it. It's going to look really pretty and that's great. But it's now what can you do with it? Because without that group by, you're not able to do this.
Yeah, and I was starting to actually type that, but then realized it's just down below. So it'll save me some typing. So yeah, you'll be able to see the power of that group by here in just a minute once we get through this arrange one. So arrange function, it's similar, but now you're ordering on continuous variables. So you can see here, arrange descending petal length is going to be what we feed it. If we look at this, so petal length, it's descending. It defaults though to ascending. So if we were to actually run this again, but without the descending in there. Okay, so again, you see here the output, when we said descending, our values are going down with petal length. And now if we run it, if we take the descending out, we rerun it and look at the head of me again, you'll see petal length is now increasing or ascending. So just note with the arrange function, it automatically does ascending unless you set it to descending. All right, so here's where we're going to see the real value of that group by is when we want to start doing some calculations based on different groups within our data. So, and we use the summarize function for this. So what this is going to tell us here is that we're going to take our iris data frame. We're going to group by species, just like we did a little bit earlier on. So now we're going to have Setosa and then versicolor and then virginica. We'll have 50 of each, all grouped together. Then we're going to use the summarize function to do n equals n and then in parentheses. So n is the same as saying we're going to do a count. So we're going to do a count of how many observations are of each species type. We're also going to calculate mean S length, which is going to be the average of the sepal length within that group. Okay, so that's what we're telling it to do here, is basically calculate two new variables for each separate group. So we should end up with a count and a mean sepal length for all three groups. So let's take a look at this and see what it looks like. All right, and then we'll look at M2. So here we have our three species, and we have two variables or two new variables for each species or each group that we told it to group by. This makes sense because we saw earlier on when we ran the summary function of iris that there were 50 observations of each species type. And then it calculated the average sepal length for each type of species here. Brad, you want to add any more here?
No, and the one thing I'll remind you, and the one thing I'll just jog your memory on here is we're not expecting you to memorize all this, okay? What we want to do is expose you because this is the stuff we're going to keep coming back to. So when something goes wrong or something breaks, don't be scared to ask questions. Don't be scared to be like, hey, Brad, that didn't work. Hey, Catherine, why did you do this again? We'll walk you through all that. Part of this is exposure, and then we'll repeat the process over and over again throughout the semester, okay? Part of what we're showing you now is the stuff we're going to keep coming back to from now until the end of the term. You know, with me on that? So again, first exposure, and then we just keep coming back to it.
Yeah, and we wanted to expose you to the Dplyr package when it comes to data wrangling, just because, you know, for those of you that haven't been coding for a long time, which I know are the majority of you, this can sometimes, for a lot of people, this kind of logic and thought process flow can be helpful when trying to clean data. It was really helpful for me. I have not been coding near as long as Brad has. So this worked well with my thought process behind how I needed to manipulate my data when I'd go to get it prepared for analysis. And I've seen it work for a lot of other students along the way. So this is just a tool to have, and these are just a few of the functions that exist in Dplyr. There's a lot more ways that you can manipulate your data, but this is just, you know, kind of scratching the surface of that. And
just to add to that, there's not a right and wrong way either, guys. There's a million ways to do this. Okay, that's it. Traditional programmers get mad about R because there's so many different ways you can do things. I know Catherine and I want you to do things that make sense to you and come up with your style for this stuff, okay? And you'll start to develop that as the semester goes. So this is one of those things where logic matters when you get to the end, but how you actually implement it, if you implement it a way that we haven't, or if you implement it a way that's a hybrid of the styles or whatever, however you get the job done gets the job done, okay? So just remember that there's not a right and wrong way. All we're doing is exposing you to this stuff.
All right. So I think this is our last topic, is reading data into R. Brad, do you want to take back over?
We've only got like a minute here, but we'll open up with this on Wednesday. But basically what I'm going to do is really quick on Wednesday, show you how to read in a couple types of files and how to create your own data and store it. And then we'll be off and running on plotting stuff.
Yep, and I will send out the RMD that you all will need for all of the plotting material that we're going to do. I have taken a look at all of what Dr. Fraser had there in module 3. So we're just going to be building upon that. And I'm hoping to still be able to get through that module the rest of this week. We might run into next Monday a little bit on that content, but we'll see how it goes. Yes, Sam.
When is assignment 2 going to be open and due?
We'll get that posted up today or tomorrow. I think we've gotten through the majority of this content, so we can get that assignment 2 up today or tomorrow. And again, we'll give you 7 days to complete it. So if we get it up today, and we'll send out an announcement to the class, and then that'll be for both BUDA 450 and Accounting 493C. Both classes will be in the same boat there.
And just as a reminder, guys, we're not going to make something due when we haven't finished the content or haven't finished 95% of the content like what we have now. That's part of the reason we've held it to this point, is to make sure you all were aware of this, you know what was being expected of you, and then we'll do +7 from the assignment day, okay? It's always a full week to get it done, nothing shorter than that, we guarantee it, all right?
Great. Any other questions? All right, well then we will see everybody again on Wednesday.
Thank you. Have a good day.
Thanks, you too.